So this is methylpropane. Next. Now we go to pentane. 5 carbons in a row. Longest chain 5 carbons. So we count the number of hydrogens, it's 12, C5H10, or 12 rather. You're going to find that the general formula for alkanes is you have n number of carbons, double that, and then add 2. So this is going to be 2n plus 2. So the general formula for any straight chain alkane, make that up there, is CnH2n plus 2. And that's what we have there. Okay? Now, let's go to the next page here. So, this is what we have for that. We'll put that on there like so. There's 4, and then I'll put another one right here to make that 5. Now, I will tell you that this is really a rather unstable structure for pentane. It likes to be as close to as a sphere as possible, or a circle if you will in this case, because there's a lot less resistance to motion this way. It can take on various forms. Well, we're not going to spend any time on that. Just want to let you know, it isn't straight. Most of the time it's not. It's actually all balled up, because it wants to travel around with the least amount of resistance. But here's your 5. If I take this one off right here and put on the next carbon over, I now have this compound. This is no longer a pentane. This is now a butane. So, and you got a methyl group right there, so the name for this is methyl butane. One word. Now, let me move this methyl group over here and see what happens. Are these 2 different compounds? Are they totally different from each other? Well, here's my structure for that right there. If I turn 180 degrees, you got that one. So these are identical. So it isn't a matter of left or right, because molecules don't care what's left and what's right. They care about how far it is from an end. So this is 1 carbon from an end, and this is 1 carbon from an end. Same distance from one of the 2 ends, same compound. So they are both considered to be methyl butane. The last one I'm going to go through are, actually no, there's a couple more I guess. Let's do the hexanes next. So I'm going to put this on the end. Oh, wait, we got something else. Oh, we got one more isomer for this. I forgot. Ooh, that was close. Get off of here. What's wrong? 1, 2, 3, 4. Oh. Come back on, just kidding. We got the 5 again. Now, let's start with this. Let's go with this one right here. These are the same thing. I'm going to take one off of this end and put it on that middle carbon. Yeah. So, I got this one going here, and I got this one going here, maybe, and I got this thing. Now I'm trying to get this all, my hand is obliterated. There, that's what you got. 3 in a row, 1 on top, 1 on bottom. So that's another isomer. Now, how do we name this compound? Well, we find the longest continuous chain of carbons. Three carbons. So this is a propane. What do we have attached to it? Well, to this green circle here, we have attached a CH3 here and a CH3 here. Now, if these were bonded together, that would be a C2H5 group, which would be an ethyl group. But these are both methyl groups. And the fact that we have two methyl groups, we have to identify in the name of the compound. And the prefix for two, like for the hydrates, is di. We're going to use the hydrate prefixes for the number of attachments. So this is dimethylpropane. If you count all the number of carbons and hydrogens for all these are all C5H12, which is what makes them isomers. Same formula, different structure. So when you get a bunch of the same formula but different structures, like we had 2 isomers for C4H10, we got 3 isomers for C5H12. Now, let's take a look at C6H14. That's the formula for hexane. Hexane. 6 carbons in a row. Hexane. Off there, put you on the end. Take you off here, put you on the end. When I taught organic chemistry, we had students that wanted to buy these little kits that I was using. It's a waste of money. I mean, if you want to do it, that's fine. If you like to play around with possible structures and how they're the same or different or whatever you want to prove it to yourself, that's fine. But these things go for about $100 for plastic pipes. Get dots, candy, and toothpicks, and then eat your answer. There you go. Anyway, that's what I used to do. And that's why I look the way I do. Okay, so now we're going to take a carbon on the end and put it on the next one. And it makes no difference which end. I'm going to go on this end right here, so I'm going to put it right there. So this is what it's going to look like. Mrs. Johnson hates this when I do this during the regular school year because I'll get all these on there and she can hear them. Drives her a little crazy. So we have here what we call methylpentane. So let's put that down. Methylpentane. Now, just to see if it's different, I'm going to take this carbon off here and put it over here and see if it's the same thing or different. And so it looks like this when I draw it on my 3D with Professor Peabody. Is that different from that? Well, if you take a look at the carbons to the left and to the right of the carbon that contains that methyl group, you got 3 here and 1 here. You got 2 here, 2 here. That's different. This is going to have to be, we're going to name it methylpentane, but it's got to be different from the other methylpentane so we can tell the difference between the two. And the IUPAC states that when this happens, you have to number the carbon at which you find it, and it's got to be the lowest number possible from one end. In other words, in this case right here, this carbon right here in which we find the attachment is the third from the left and the third from the right. It's the same no matter what. So we put a 3 in front and call that 3-methylpentane. Okay? Over here, we got 1 on the right, 3 on the left, so that means that if you go from here, this is number 1, and this is number 2, so that would be number 2 for that carbon, where we find the methyl group. If you go from this direction, 1, 2, 3, 4, that would be a 4 for that. IUPAC states you must pick the lower of the 2 options. The lower of the 2 options here is 2. So this is 2-methylpentane. Now I'm going to move it 1 more. One, 2, 3, 4, 5, 6. Well, sure enough, that's another methylpentane, right? So we isolate on this carbon right here. And if we go from the left, that's 1, that's 2 there. If we go from the right, it's 1, 2. Sorry, it's not ended, so I got that. And this is going to be 1, 2, 3, 4. Well, we can't, choice of 2 and 4, it's a lower number, that number is 2. So 2-methylpentane, but wait a minute, that sounds really familiar. Oh, yeah, it's the same as that thing. If I took that, methylpentane I have right up there, which will not look like that. This over here. Okay, now it'll kind of look like that when we get things all fixed. That's my 2-methyl. If I flip that 180 degrees, sure enough, I get that. I get the same name. So this is not a different isomer from the other. I already named the 2-methylpentane previously. All right, so now, are we done? Oh, no, I don't think so.